Boy Marcus here with another video on SpriteKit. If you haven't been here before, we are learning the SpriteKit framework to make a 2D game called Asteroids, and yeah, we've been making some progress on this game. Let me go ahead and run it so you see what the game looks like. It's basically this clone of the 80s arcade game Asteroids, where you fly a spaceship around and shoot asteroids for points. We have the same game pretty much, except that our UI is a little different. Instead of asteroids, we have asses. So that's how our game is different. Right now, what we are trying to do is trying to move all the asteroid functionality. So there's a bunch of code that pertains to creating asteroids and managing collisions. What we're going to try to do in this video is move all that code into its own class called asteroids. So real quick, let me go ahead and show you the game once it boots up. Any moment now, if this would just hurry up, please. Hope you're doing well, guys. It is a cold evening here in Los Angeles, which means it's 55 degrees. That is pretty damn cold for California. I don't know how it is anywhere else. Probably, I don't know, some places it gets to -10 or something crazy like that. California would not survive. Even the slightest bit of rain makes drivers unable to operate their vehicles correctly. You know, we just can't handle the cold. And that's what happens to Californians. So here's what the UI looks like. This is our spaceship, the thing that's flying around with the little flame coming out. That's what our spaceship looks like. We're able to thrust the spaceship and send it flying across the screen. We can pivot the spaceship by pressing the left and the right arrows right here. And lastly, we're able to shoot missiles. So we shoot missiles. The missiles actually go pretty fast. They're shooting across the screen. And another thing is, you'll notice that the missile wraps around the screen. So if a missile goes off the screen, it'll wrap around to the opposite side. So that's what our game looks like right now. That's where we're at. We're not going to change the UI or make anything function differently in this video. We're just going to move the code like I mentioned before. So this is our main class called Game Scene. It is a huge class. I think it's like 800 lines of code. Really, we want to get it's 748 lines of code. So 748 lines of code. We want to pare that down to about 200 lines of code. So we have a lot to do. But it's okay. We're just slogging through it one day at a time. But let's talk about what we're doing in this video. So I'm just going to scroll down here and check out the specific function that is creating the asteroids function. I like saying method, but function method, I'll say either one, same thing. In the context of Swift, because everything is inside of the class. Function inside of a method, some function inside of a class is called method. So anyway, so we are generating asteroids right here. We have the generate asteroids method. It's a big fat method. So let's check if, first of all, let's just do a quick commenting out of this method to see if we actually ported it over and removed it correctly. So I'm commenting this section out because it happens to be in another video. We wrote some code to create asteroids in a different class called asteroid. So if this is correct, then we should be able to create asteroids this way. So we need to make a call to the asteroid. So the asteroid, actually, before we comment this out, let's see what we need from this method. Okay, so I know that we want to give the asteroid a random starting position and a random coordinate. So what we're doing is we're setting random coordinates right here, either positive or negative x and positive or negative y, and then we are choosing between them for the x and y coordinate, and then for the position we're plugging those in at random to the position. So instead of passing a position to the asteroid, maybe we should so what I mean to say is instead of having this whole body of code that sets the position inside of this method where we generate asteroids, maybe we should do all of this setting of the position inside of the asteroid class, like right here somewhere. Because it's the case, after all, that we're running all this position setting for each and every one of the asteroids, because with each loop of this for loop, we're actually just creating one asteroid with all these properties. Yeah, so we're setting the position randomly. That's one of the main things. And then we're also creating the physics body. So we want to set the physics body as well. So let's see if we already created the physics body. Okay, we need to, so we're calling the physics body method here. We don't have anything inside of the actual definition or the actual method body. So let's do that. Let's do that. So we'll just copy for now all this into asteroids, and instead of sprite node, we're going to say self. God, this keyboard is awesome. If you want a keyboard that's not a gaming keyboard but is really high quality, just get a DOS keyboard. It's for productivity and office work. It is an excellent keyboard for typing. It's just fantastic. I got the most basic model, but even that is head and shoulders above anything else I've ever used. Okay. So we don't have a velocity, I guess. Let's go back to game scene. Where are we getting the velocity? Velocity. Velocity should just be part of the physics body. are we adding a physics body? Sprite node physics body. We're instantiating a physics body right here. We're adding a physics body. So are we doing that in our asteroid class? We'll say self.size. Maybe that'll fix the error. Can't find velocity in scope. Cannot find velocity in scope. Why is it doing that? Velocity. Oh, because we need all of this. Int.random. So this randomization of the integer doesn't require any information from the lines above it, so we could just copy this and then give it a velocity. Let's go into asteroids and freaking give it a velocity, man. Perfect. So that should take care of it. We cannot find asteroid category in scope. We cannot find missile category. So this is part of the problem. Here we need to worry about the bit masks. Both the category bit mask and the contact test bit mask. So just a refresher on this, the bit mask is a uint, so the data type is uint32. So it's a special data. It's like an integer except it's represented differently. Basically like a different base kinda. So a number is represented in basically binary, but there's a few letters in there. But anyway, that acts as like a certain identifier for a physics body. So you can assign that uint, aka category bit mask. You can assign the category bit mask, which happens to have the data type uint. You can assign that uint to a category and make that category give that identifier to the category. So let's see what we mean. So this category bit mask on the self, this whole class, or the object instantiated from this class, is going to be set to asteroid category, and that's a variable we set in the main class. We just gave it a uint value. So here are our uints that we created, and we're using these uint values. See how they're kind of like binary a little bit, but we're using these uint 32 values, and we're using those as the bit masks for this physics body, which again is this physics body is assigned to the object instantiated from this class. So in particular right now we have several physics bodies, or several categories. We have the missile category, the asteroid category, medium asteroid category, and the small asteroid category. Now, I think we're going to need all those different categories because the code needs to distinguish between the different sizes of asteroids. So we have large asteroids in our app. Let me do it this way. And then we have medium, and then we have small. And those do different things. So the large ones need to be distinct from the other two, because the large ones need to turn into medium ones, and then the medium ones need to be distinct, meaning they have their own uint 32, because they they distinctly break into smaller asteroids, the smallest asteroids, and the small asteroids do their own special thing, which is to disappear from the screen. So that's the way I'm thinking about it right now, that we need 3 different identifiers. So right now, first of all, I want to refactor this asteroid category into large asteroid category. So let's do that. Large asteroid category. And then this is going to be another refactor. This is going to be medium asteroid. Notice I'm putting an S here. AS asteroid, because we have asses in our game. I farted. Beans, the magical fruit. The more you eat, the more you toot. So that is refactored. So when we create the physics body in our asteroid class down here, we need to assign it an asteroid category. So this needs to be large asteroid category. Large asteroid category. And we need access to this large asteroid category. So what we might be able to do is we can just define the large asteroid category in this asteroid class as a property up here. We might be able to do that. And what we might be able to do is, but the thing is, we need the missile category. So maybe in the asteroid category is where we also have the missile. But really the missile the missile should belong to the spaceship. So we have the spaceship here. The missile should belong to the spaceship. We have the thrust that belongs to the spaceship. Yeah, so that's what we'll do. So in here at the very top we have the missile category. This will go into, I think, the spaceship class. Or maybe it's because it's its own object. We can define it in the missile and create a missile each time, depending on how much code there is. So this is kind of a tangent because we're thinking about the missile, but the main thing we want to do in this video is be concerned with the asteroid generation and all the functionality that has to do with the asteroid. But I want to think about the missile too, because the missile is the main thing that interacts with the asteroid. So I have to think about the interaction before I split everything up. So let's be concerned with the missile for the time being. So this is all the code that creates the missile. And you can see we already have all the missile creation. So I forgot that we did this. So we already create the missile and it's working, I think. Let's actually test if we have the missile in our game scene. Hopefully we don't, which means we successfully removed it from this game scene class and defined it. We defined it in our game scene. So we have fire missile. Let's go to definition here from this part. Jump to definition. I guess the definition is right here. We're defining a missile. We're instantiating a new missile right here. Let's change this to a let constant. Because Xcode wants us to do that. But, okay, so we have our missile functioning already. So we're done with the missile, basically. So how was it managing the collision then right now? Because we're calling fire missile. And we are... passing a missile category and a large asteroid category. So what's happening in the missile node when we fire the missile? So we're accepting a missile category, medium asteroid category. Okay, so let's refactor this. We'll call it large asteroid category. Asteroid category. This is a medium asteroid category. Let's refactor that. Medium asteroid category, 2 S's. Might as well refactor as we go. So this is incorrect in the call. This call right here, because we're passing it the missile category here, and we're passing it the missile category here. It's actually accepting it because it's a uint 32, but we actually want to be passing it the medium asteroid category, because that's what we have in the definition for fire missile, this function right here. So that call makes sense technically, but I don't know if it's optimally coded. Because we do want to fire the missile, but I think the collision should not be handled in the missile class. So we have missile node, and then we fire the missile. What does it do? We're applying the force. And then we return a date. I'll get into that later. So we apply force. We're applying the force, and then we are setting the categories here. I don't get that. We're setting the contact test vent mask. Is that how we have it? Is that how we had it before? Why is it these two? I think it's supposed to be large and medium. I think it's this, or this pipe is supposed to be missile category and large asteroid category. Yeah, so how do we have it here? Yeah, we had asteroid category, medium asteroid category. I don't think that's right. Okay, so let's ask ChatGPT. So we need to ask our question carefully. Basically, we want to find out if this line of code right here, this bit of code that is concerned with the large asteroid category and the medium asteroid category, if this code is correct, because what I think is it's supposed to be a missile category, and then it's also supposed to be either large or medium, and then on the flip side, on the other side of the pipe, it's supposed to be the missile. So let's ask ChatGPT if that is what needs to happen. So we'll say, paste that, we'll say, please take the names of the variables into account when providing your answer. Let's get another one of these. Let's get this line of code too, just to give ChatGPT more context. Okay, please take the names of the variables into account when providing your answer. These names should connote. These names should inform you better about what is happening. My question is, do I need to combine, do I, with the pipe operator, need to combine the missile with an asteroid category, with either of these asteroid categories, in order to handle the collision between a missile and an asteroid. So let's see what answer it gives us. So we're gonna press enter, please. There we go. This is kind of fun. I love coding. Coding makes me forget about anything. Coding is awesome. Coding is therapy. So what does it say? Okay. What does it say? So ChatGPT says, no, you do not need to combine missile category with the large asteroid category or medium asteroid category using the pipe operator to handle the collision. The pipe operator in this context is used to specify which categories of objects the missile's physics body should respond to in contact detection. Here's a detailed explanation, taking the variable names into account. What happens in the code? So self.physicsBody categoryBitMask missile category. This line specifies that physics body for this object, e.g. a missile, belongs to the missile category. The category bitmask indicates what this object is in terms of its category. Okay, so the identity of the category of the missile is missile category, which we've created earlier. It's the uint32. Think of it as assigning a label to this object. So yeah, we get that. So the next line is self.physicsBody contact test bitmask large asteroid category medium asteroid category. This line specifies that the missile's physics body should detect contact with objects in the categories large asteroid category or medium asteroid category. Before I keep reading, I'm just going to ask it if it's sure. Because I'm not sure I trust this. Yes, I'm sure. Okay. Yes, I'm sure. Okay. So let's go ahead. That's the surest I think I'm gonna that's the surest I think ChatGPT is gonna get. So the pipe operator combines two asteroid categories into a single bit mask, effectively saying the missile should detect contact with either large or medium asteroids. Why you don't need to combine categories. The category bit mask of an object, e.g. missile category, and the contact test bit mask of another object, large asteroid category or medium asteroid category, are independently compared during contact detection. When two physics bodies collide, SpriteKit checks, does the category bit mask of one object match the contact bit mask of the other object? Does the reverse also hold true? Okay, that makes sense. Alright, then I don't understand why we wouldn't have a small asteroid as well. So let's make a small asteroid. Small asteroid category, and let's define a. This is kind of messy, but asteroid category int 32. Okay, so that's what it is. So we're telling the missile to watch out basically for these. So we do need a distinct large, medium, and small category to be assigned to small, medium, or to large, medium, or small asteroids. But as far as the missile is concerned, it knows what it is, which is it's labeled missile category, and it's going to look for large, medium, or small asteroid categories. So that's what happens when we fire the missile. Let's get rid of this to do. Let's do this. get rid of meow. Meow, meow, meow. So that's all good. What I think the missile is doing. So that's good. So now we need to handle the collision. So what are we returning? So how does the missile understand? Okay, so right when the missile is created, so we're going to create a missile. And then right when we create a missile, we're going to call create physics body. Okay, right away. And then we are going to fire the missile. So I think we can just call fire missile as well when we create the physics body, no? Because when are we ever gonna create a missile without it being fired? So I think this calls for another refactoring. So let's see, when we press the trigger node, let missile, so we're creating the missile, putting the missile on the screen, and then we're calling when missile fired. Equals missile. So my question is, when we instantiate missile node, can't we just fire right away? So that this call is really easy. Why are we doing it 3 different steps? Can an initialization return a value though? Well, actually the value would be missile node. Yeah, that wouldn't make sense if we got a return, because the thing that we're need to get whenever we instantiate an object is the object. It shouldn't return something else. So I don't think we should do that. Yeah, I guess it's okay like this to have the separate call. So the thing is, why are we not just giving these category bit masks to this object when we create it? I guess because we don't want to give it 2 categories. We don't want to give it large and medium category, because then it doesn't know what it is. Well, actually, it wouldn't know that anyway. So can we just make a really long object here? Can we do that? Why not? Yeah, I think we're getting on a tangent right now. We're supposed to be doing the asteroids, but we're concerned about the missile right now to make it more optimal, which is okay, I guess. So we're creating this object. creating this object. I guess it makes sense. I don't know. We can do it however we want. I guess it's logical to be concerned about the category whenever we fire. Yeah. Or at least I think we can give it the missile category. No, I guess it's logical. Everything that has to do with the collision, all the categories are passed when it fired, so that's okay. So we're concerned with large, medium, and small, so we're actually not going to refactor that. So we're going to call this with an argument, small asteroid category. There we go. I guess that's it for the missile. Oh god, it's getting to be pretty late right now. I was only going to code for 20 minutes, but it's been 45 minutes. Alright, I guess we could go just a bit longer. So let's pivot our train of thought here back to the asteroids. Generate asteroids. So all of this is an instant. Oh, whoops. So all of this here is just creating an asteroid. That's what it's doing. So back to setting a random position. So what were we in the middle of doing? We were giving it a physics body. So this should be okay. So we want to use the same class to instantiate all the different sizes, large, medium, or small, depending on what we need. So let's just change this to asteroid category, and we need to accept an asteroid category. So we'll say, without an argument label, we'll say asteroid category. Right, category, and then we will call it a uint32, and we'll do the same thing in the other init method. I explained why we needed another init method in another video, but basically we have two different ways of initializing an object. So maybe we can give it a default value here. We'll say, what's a default value we can give it? I think with default values we don't have to conform to the protocol. I think that's how it works. So let's, for the default value, let's just give it the large asteroid category. And I think Xcode will stop complaining that it's not conforming then. So asteroid. So how do so I can give it another init method, like a third init method, but I don't want to do that. Kind of defeats the purpose of the protocol, because then why would I have the protocol if we're just going to create our own init methods for each each class. So let's change the protocol to asteroids. So we'll say physics node protocol, and we'll give it a u int. We'll say asteroid category, and we'll say this is a u int 32, and we'll do the same thing right meow. Asteroid category u int 32, and now when we go back to the asteroid class, yeah, it stopped complaining. Perfect. So we have no more errors, at least right here where we are in this file. So, oh no, we have this error. So we have asteroid category. Required init. So category bitmask. So we can just literally just give it a category bitmask right here. Oops. So we could say up here we can say var category asteroid category asteroid category, and this is going to be a u int 32. And then we could say self dot asteroid category equals asteroid category, and then do the same thing in the other initializer. Dude, I love coding. Coding's fun. We could do that, and then we don't have a missile category. So we need to pass in a missile category. Yeah, this protocol is getting super long. This protocol. So we do want to set the missile category, but can we set the missile category in another place, like when there's a collision? Actually, it won't detect that there's a collision without the missile category. So I think we need to add to the protocol too. I think we might change the protocol, even though we spent a lot of time on it. Just because, I don't know, it just is pretty long. There's a lot of extraneous parameters because we're kind of accounting for all the different objects that could be instantiated with it. Missile category. This is going to be a U int 32, and then we need to do the same thing in the other initializer. Here, and then we need to put that into the protocol. So let's go back to Asteroid. So Xcode. So this isn't. What is it saying? Property self.asteroid is not initialized at super init call. So the missile category is always going to be the same. So we actually don't need the missile category. We'll just hard code that in. So let's erase that. Let's literally just immediately go back on what we just did. Fix the physics node protocol. Let's create a constant. So we'll have the missile category. We'll have that as a constant. That will never change. So we'll say static let missile category, and then when we go back to game scene, we'll say missile category uint, and then we'll say k dot missile category, and then we will category. Let's find all the missile categories. So there we go. That should be initialized. There we go. There we go. There we go. Let's go back to the asteroid and let us just put this as a constant. Oops. K dot missile category, perfect. And then let's initialize this. Let's make it constant for all of those. Yeah, why not? Let's make it constant for all the categories. Easy enough, right? So let's do this. Let's copy all this and create constants. static let. Static let. By the way, this is an enum. What we're doing here with the enum and these static variables is we are making this whole class and all these properties, these constants here, we're making these available throughout the entire project without having to instantiate any objects and then using the dot operator, for example, to access any of these properties. We can just type in k and then dot and then access all these. And the reason we do that is we define it one place in this enum, and then we could just write k dot, and we know that the values for each of these constants are going to be populated correctly because these never change unless we change them. But then we only need to change them in one place, which is the enum k. So that's why we do that. So let's write k dot large asteroid category, k dot medium asteroid category, k dot small asteroid category. And then we actually don't need to pass any categories to the missile then. We could just write category. We just write the constant everywhere. So we could say var missile category, missile category equals, we'll say uint. I just like the data type whenever I write a variable just to make it very clear. So uint, and then we're going to go k dot missile category. Wow, this makes it way easier. So we'll go let's try let we'll say large asteroid category of type uint 32 equals k dot large asteroid category, and then we'll say let medium asteroid category equals uint 32 equals k dot medium asteroid category. Let small asteroid category equals uint 32 equals k dot small asteroid category. So that way we don't have to pass the asteroid category. So let's take that out of the physics node protocol as well. Actually, I don't think we should take that out. Maybe we should just put a string in here. It says size. We can say asteroid type. And then this would be a string. So what I'm thinking of is we can have a string and then just pass the string to the asteroid object, how are we going to do this? So when we create the object, we want the flexibility to create a small, medium, or large depending on whatever we pass to the object or pass to the class. So I think we do need an asteroid category because we're going to, yeah, we'll pass the asteroid category from the, I guess we'll pass the asteroid category from the, no, what are we going to do? So whenever we create an asteroid category, whenever we initially create the large asteroids at the beginning of the game, so this is tough. Alright, so we've been coding for an hour. I have to go to the bathroom and I have to work on something else. I'm trying to start a side business. So let's write a to-do. I'll do this next time. So let's see. Figure out how to allow how to flexibly create small, medium, or large asteroids depending on what some certain parameter that we pass during instantiation of the asteroid object. Okay, so that'll be a to-do for next time. I'm also going to write the to-do in the generate asteroid thing method we have down here somewhere. So that'll be it, guys. Appreciate you tuning in. I'm just going to commit right here. Refactored and decided that will flexibly, is flexibly a word? Flexibly create small, medium, or large asteroids depending on the category that we pass to the initializer when we create the object. Let's do that. Dun 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 dun. Re-authenticate. Okay, so I'm just gonna cut it there. Guys, make sure to smash, destroy decimate, decapitate, and annihilate, and why not obliterate that subscribe button. Tell all your friends. Write this channel's name on the side of your sports car. Spray paint the name of this channel onto your dog. And I will see you soon. Peace out.